Good morning, good evening, good afternoon, depending on where you are and depending on when you are watching this recording. Welcome to the next Azure Security Expert Talk in our series. Today we are going to talk about access control in Azure. Very briefly, let me introduce myself. My name is Karl Ots. I'm a cloud and cybersecurity expert. I've run multiple communities, organized conferences, spoken and presented, run and organized conferences, authored courses, papers, and so forth. I've been working on Azure since almost 10 years now, and specifically from the security point of view, I've helped to secure hundreds of different Azure environments, and they have varied really from startups, hopefully with a global scale at some point, all the way to Fortune 500 enterprises, where I'm working right now as well. I'm a Microsoft Azure MVP and a regional director. Today we are going to cover three key topics related to Azure Access Control. First, we talk about authentication, different identity providers available to us. Then we move over to authorization. And finally, we spend quite a bit of time on providing access from one service to another in Azure and providing access to users that might use our Azure applications. So this will be a very action-packed session, and we have lots of materials and lots of demos. Don't worry if you miss something. You will have everything available in the Scale Me Up recordings. Okay, let's get started. First of all, many businesses right now are transforming rapidly to compete with digital native startups, and this really changes how we drive the security as well. We really start from this classic enterprise security strategy with a no network perimeter and really this firewall around our trusted network, and everything out of that is unsecure. And we will add some mobile device management and maybe even some private access points for our mobile devices to access our emails and other internal systems. But with this adoption of software as a service, we really need to think of other modules, other ways of really supporting this plethora of applications who we really cannot consume in a single tenant way. We cannot put these within our own environments, within our own network perimeter. And when we evolve across this adoption path, at some point, we really need to have this first-class mobile experience as well. And we maybe need to procure some mobile device management with different sets of conditional access, and maybe even support bring your own device self-enrollment of those devices as well. We no longer are able to just rely on IT-provided laptops, workstations that are pre-provisioned and that are secured from the ground up. And finally, the approach of cloud technology and new technologies that really disrupt our fields, be it Internet of Things or any other new fancy service that our business will want to, this really blows up our capacity to just react and protect from this perimeter point of view. So really this current modern enterprise security perimeter should cover and support all of these, and maybe even some future ones as well. And specifically, Microsoft really today talks about this identity being at the center of our security perimeter, really identity being the control plane for us. And when we talk about identity with Microsoft, we really talk about Azure Active Directory. This directly applies to Azure Infrastructure as a Service and Platform as a Service, but also software as a service and third-party and first-party applications as well. Specifically, we're going to talk about a very small subset of the whole Azure Active Directory, which is a whole cloud-native directory and provides other services as well, which can really provide us this zero trust type of access control. Today, we are really talking about Azure Active Directory and how that can be used as part of our security toolkit for securing Azure environments and Azure applications. And to complement Azure Active Directory, Microsoft provides us multiple signals and multiple touch points to data that they themselves use to run and secure this one of the largest identity providers there is, with hundreds of millions of authentications happening every day. Microsoft has a ton of security researchers. They have their own, of course, they subscribe to the threat feeds. They have their own sample zoos, honeypots, sinkholes, and they work very actively with law enforcement to gather this intelligence. They can't really give us this raw data, but they can actually collect and normalize this data so that it's pseudonymized and available for us through maybe not direct APIs, but at least some threat scores. And below here, you see these different interpretations or different viewpoints or portals to Intelligent Security Graph, which is just this branding term, umbrella term that covers all of these different views. Anytime we see any threat information related to an Azure Active Directory login, anytime we see any threat information related to any suspicious activities, malicious botnet IP addresses, and so forth, that comes from the Azure Intelligent Security Graph. And then that's something that we can raise an alert on and react and remediate based on our own patterns and playbooks then. Okay. And when we start to adopt Azure Active Directory for securing our Azure environments and Azure applications, we quite often or quite fast need to consider, is this something completely different from what we used to do? Are we integrating with existing tools for identity provisioning and other identity management processes? Should we have completely separate admin credentials for the cloud stuff? That's something completely different. Should we have replicated just the accounts so that we will cognitively need to switch gears, switch our hats from our regular user to our admin user accounts? Should we have completely disconnected cloud-only Azure Active Directory? Or are we following some existing AD forest structure and replicating something like that in the cloud as well? And finally, external access is really something that we need to think about. By default, Azure allows us to federate with essentially a wildcard federation with everyone who has an Azure Active Directory, but also everyone who uses a trusted identity provider. And among them, we have Gmail, Outlook.com, and many others. Microsoft even recently introduced one-time password logins, meaning that just anyone who can gain access to an email account and receive a one-time use password can log in without an actual identity provider being there and verifying any authentication. So should we trust our partners? Should we have a process of onboarding partners, verifying that they have their own MFA and other controls in place? Or should we onboard those with the same processes that we use to creating on-premises AD accounts, synchronizing them to Azure AD, and so forth? And even more, we need to consider when we move further and closer to production in Azure, we need to consider the fact that Azure Active Directory actually comes with only 3 nines of SLA. So should we have some sort of break the glass accounts when and if and when there is a disconnection between our on-premises Active Directory synchronized to Azure AD? Should we have some cloud-only accounts that have some privileges, maybe some very high privileges in our Azure AD environment that can take over when everything goes wrong? Should we provision some central accounts into each of our Azure security groups, service principals, and Azure environments, Azure subscriptions, just so that we can take back control, we can help our quite often very self-driven, very agile, and independent development team? And speaking of that, one part where I quite often see organizations struggle is really this continuous deployment access and the roles that a single developer will need in the Azure Active Directory side. Will they just have the power to just create service principals on their own and use those credentials and authenticate from the CI/CD pipelines from Azure DevOps or wherever into the Azure environment and go from there? By default, that's perfectly possible. Any regular user in Azure AD can do that. We might want to think about limiting that to be available only to certain Azure AD roles. There are a couple of built-in roles: Azure AD Application Administrator, Azure AD Application Developer, who are able to manage and create those service principals. And then we can flip the switch in our whole tenant so that these activities are not available for regular users. But by default, this is available. It creates a lot of power for the dev teams if they know what they're doing, if we trust them, if we have other ways of controlling. That's very nice. But quite often, the case is that the devs might feel that this is then left still responsible. This is still left for the responsibility for the IAM teams, as this is something to do with Azure AD. Okay. So we talk about this Azure Active Directory identity, which is synchronized from our on-premises. For every single Azure Active Directory, for every single Azure resource assignment, Azure role-based access control assignment, we always link that assignment to our home Azure Active Directory. By default, that is something that we can actually extend. So each B2B guest actually appears as they will be, from this point of view, appears as they will be within our home Azure AD identity. But this already provides us with a little bit of extra trust. We can assign Azure access to any single user in our Azure AD or invited as a guest to our Azure AD. We can assign Azure role-based access control to any Azure Active Directory security group, which can be synchronized from our on-premises groups as well, or can be also dynamically created in the cloud based on some conditions. Hopefully, they are somewhat connected environments. And finally, the role-based access control can be granted to system accounts or service principals, as I mentioned. And the Azure Active Directory service principal is something that by default, any user can create on their own, any real user, not a guest user, in Azure Active Directory. And they can also assign, or they can also select how does that identity actually log in? By default, they log in using a username and password, a key value pair of secrets that gets generated and is valid for, by default, 2 years. This is something that you might want to have a look at, maybe enforce some key management there, enforce maybe shorter life cycles, actually integrate that with so that you will have some alerts coming from your Azure AD. Service principal is nearing its end of life cycle for the key. Hey, let's raise this alert for the owner of the service principal, which by default you don't even need to have. So again, something that you maybe want to enforce. Or you can even have certificate-based authentication instead of that key value pair. Okay, and Azure Active Directory identity, service principal, user, or a group is then combined with the scope within our Azure environment and a specific role or the actual authorization, the access part. And all of this together is one role-based access control assignment. A single user or single Azure AD identity can have multiple of these at a time, and most likely they should have. And these are always default allow. We don't have a deny type of role-based access control. And let me illustrate this by doubling down on the scope part of that role-based access control. So what is the available scope? How widely does this one role-based access control assignment actually affect? And the effect of a single role-based access control assignment is at maximum a management group, which is a virtual folder of subscriptions. There can be even several tiers of management groups. So we can have a higher level management group that encompasses multiple management groups, which each other encompass multiple subscriptions. And the higher we assign this scope, the longer it actually gets inherited. So if I would assign my access here in the subscription scope, I will get, let's say, a reader access in the subscription scope. Whenever any other user creates new resources in this environment, I would automatically get access to see and read those resources as well. It's perpetual access to any resources that are in that same scope and inherited from that scope. If I only have access to a resource group, then I have access to any resources now and in the future within that resource group, but I won't have any access to the other resource groups, present or future, in the same subscription. So like any good things, role-based access control assignments flow downwards, get inherited. And besides the identity, besides the scope, the third part of the role-based access control assignment was the actual role. And we have maybe 200 right now built-in roles available. We have service-specific roles, such as virtual machine contributor, but we have generic roles as well, such as monitoring reader, security reader, and so forth. And we have these 3 roles on the top of the list that Microsoft really likes to promote as the default, more built-in than the other built-in roles. And there we have an owner, a contributor, and a reader. And each of these roles is actually just a list of allowed actions that you can perform against the Azure APIs. And as you'll see, the contributor role actually has star access, so they can read, create, read, update, delete anything, any resource by any resource providers, by any API within the whole Azure environment, except they cannot modify and delete the Microsoft authorization resource provider, which is meant for granting access to others. And we don't specifically limit anything in the so-called data scope. These built-in roles are actually products of Microsoft as well. So they have their life cycle, they will be preview, they will be GA, they will be end of life. And when a new feature gets added to any of these Microsoft services in Azure, Microsoft also makes sure that they make the same threat modeling exercises for these role-based access control built-in roles as well. So I would really encourage you to use these built-in roles and maybe even a combination of those rather than building your own custom roles, because then you will actually be responsible for the updates and operations of those roles as well. But you can define your role using this similar pattern of allowed actions and not allowed actions within the Azure environment. And the Azure owner role is really a combination of two main roles, a combination of a contributor and a user access administrator role. And I would really encourage you to separate the duties of this user access management hat of the owner and editing resources hat of the owner. Default role-based access control should be contributor for any of your projects, not the owner, which is the factual technical default for a new subscription. And whenever you have these project management or other user access management type of roles, you should really consider using the user access administrator role rather than the owner role. Because typically the same people don't really need to manage access to others and actually edit those resources. Maybe in the beginning of the project, but not along the life cycle of the whole environment. And I really want to point out at this point that even though the name reader sounds very promising, it's a role that doesn't let you modify anything. That much is true. But a reader does not actually let you read the data within the Azure environment. The reader does not have data pane access. A reader can go in and see the data, metadata of any of your Azure services. They can see the core count of your virtual machine and so forth, but they cannot see the data within your data services, storage, or databases in Azure. And an Azure contributor actually, in some cases, in quite a lot of cases, has actually power to modify access in the non-standard ways of access control. Azure SQL, Azure Storage Account, Azure Key Vault have all their own ways of controlling access through access policies, account keys, and other logging methods. So whenever you have full access to a resource as a contributor, as long as the specific resource doesn't use the Microsoft authorization namespace or resource provider to actually granting those access, then the contributor actually has the power to do that. So bear that in mind when you kind of lock down and harden your environment. And I mentioned earlier this data pane role-based access control. And the data pane is an extension of a role-based access control. As you saw, we had a list of allowed actions and allowed data actions. Data actions are available for us in the runtime. They are not about creating a new resource from scratch. A contributor can create new resources, but a data action could be about writing or reading data inside that resource. For example, a storage blob data contributor has read access to the resources in the management pane and even write access within the storage account's containers. They can create the containers, so the folders within the storage account, but they cannot actually go ahead and list the storage account keys. So we don't have the management pane access to modify and operate those keys, which when leaked would lead us into serious trouble. But they have direct access as long as they authenticate as themselves and they have that data pane role. They can access the data without ever needing to see those keys themselves. Okay, at this point, I will encourage you to think of any questions you might have. We will have time to go through those at the end of the session. So once you come up with a question, feel free to ask that in the chat already at this point, and I will pick those up as we go. So how do we combine these management pane and role data pane access control? Here's an example of a fictitious enterprise called Kinetico. They have a business applications Azure Active Directory, Azure subscription. And within that subscription, they have two resource groups, essentially the same application, development environment and production environment of that same app. It makes sense to grant a role-based access control contributor access to the whole resource group in development for the installation app devs security group in Azure AD. But we don't really want to have the devs give the devs full access as a contributor to our production environment. Reader is enough. They don't need to go ahead and modify who has access to the SQL or modify or list those storage account keys. And in this case, Kinetico is a green energy company. So this application is actually solar powered energy installation web application. And we have these business users here, installation manual uploaders, who we can grant access as a data pane role, storage file data SMB share contributor, which actually allows these users to use their own Azure AD credentials or own AD credentials, mount this storage account actually into their corporate laptops as a screen share, as a file share, and upload those manuals without touching any custom applications or using services like Azure Storage Explorer. And finally, we have the owner of the whole subscription that sits on the top and acts as a last line of defense as our central account for break the class type of scenarios. Okay, so when we think of granting access from one application to another application or from one Azure service to another service, we need to introduce a couple of concepts in the Azure world. We have first the conditional access and then the Azure App Service Authentication that are both very, very powerful built-in features that only require configuration, not actual development, and can get us actually very far in terms of securing the access to our environments. And let's first talk about conditional access. Conditional access lets us set Azure AD side rules on which users and groups are actually allowed to log in into which Azure applications or into any applications in our Azure AD. These can be software as a service applications with single sign-in to any other service, such as Salesforce or Microsoft's own Office 365. Or these can be applications that we build ourselves and host, for example, in Azure App Service. And conditional access can, beyond this authorization capability, actually add conditions based on the risk from that secure intelligence graph. And also about compliance. We can request that, or we can set a condition that you can log in if you're part of this group, but only if you come from a known set of network environment. So essentially, we can lock you, we can enforce you to log in from our corporate network. Similarly, we can enforce device enrollment to MDM and even specific OS version or latest updates to be installed. And we can combine this with Azure App Service authentication quite easily. So here's an example of my Azure App Service. As you'll see, it's a very simple application. It's in my demo Azure websites environment. And I can enable this application to be actually available only for trusted users from my Azure Active Directory quite easily. By default, this is publicly available to anyone. In the old world, I would have put this into a virtual network and protected that using network controls. But when my users are coming from all around the world, this is not always feasible. But rather, I can put this behind an Azure Active Directory authentication and apply conditional access. And this is just a built-in feature in the Azure App Service configuration. But of course, this is something that I can implement in application code as well if I want to provide something similar in an application that's hosted anywhere. But specifically for Azure App Service, I can just go into the authentication part of my settings blade, just turn it on. By default, anonymous access is enabled, and all users are actually redirected to my actual content page. I don't always want that. So if I go in and enable App Service authentication, and you'll see it asks me for an action to take when the request comes in as unauthenticated. The default is that they're allowed, but I can also force them to log in using Azure AD or other identity providers that I can configure here. Next, I need to provide it with an Azure Active Directory application. By default, this is something that I can actually do. In most enterprise environments, most likely I will need to actually request the creation of the application registration in my Active Directory from an IAM environment, using an existing identity and access management process. I will then need to configure that in the advanced mode in here. Once I've selected my application, I can actually go into my conditional access policies within the Azure Active Directory management portal. I can set this to apply to all users or certain users who log into my particular application. In this case, this is the application that I just created in my previous screen, App Auth Karl Demo 1. I can select that. Now this applies to any user who tries to log in to this particular application. I can set conditions related to enforcing NFA, related to the user needing to come from a specific network address space, and so forth. And for live environments, I really recommend to first enable this in the report only mode. And once you verified the access, then you can finally turn this on, because this could actually even using this, you could actually even lock yourself out if you're not careful enough. So once I'm satisfied with the settings, I have my app service configured to use Azure Active Directory to log in. I have my conditional access in place. Once I navigate to my application, I actually get the first time request after I successfully authenticate, a request of reading those permissions within my Azure Active Directory graph. I could request other resources as well. I could request to query data from your profile. I could customize this application and so forth. And once that user actually has logged in, you'll see that within the Azure Active Directory sign-in page, we see the different types of authentication data centrally. This is something that now is no longer the responsibility of the application developer to prove that they configured authentication settings correctly. This is now something that our central AD team can verify who logged in, from which device, did they use MFA, was it only username and password, was there any suspicious risk activities from the conditional access, where did they log in from network perspective or even geographically. And this helps us tremendously to configure, to monitor these applications in our ever-growing cloud environment. So we can expand this actually by talking about service-to-service access. Now that our users have logged in and they are able to log in, they're able to log into the web application. What's next? Our web application needs to get some data from a database or make some changes to an API. How do we do that? We could use system accounts such as the service principals in Azure AD, or we could use managed identities. Azure Active Directory managed identities really provide us this automatic creation of an identity in Azure AD. We can use that identity for any role-based access control assignments, and we can use that identity to authenticate into any other service that uses, for example, our other application that also uses app service authentication, such as a backend API, or any Azure data service. And this helps us to remove the need of having any credentials such as connection strings or storage account keys in our code and even at our runtime. And here's an example. So using the same example of this installation support web application, we have our installation engineer here logging in from the field, and they're logging into our installation support web application. Before they actually can sign in, they get redirected to the Azure Active Directory signing page. We have our conditional access. We check that they are in the proper security groups. We check that they have MFA, and everything is proper. They log into the installation support web application. They log into the installation support web application, and the application itself is granted, or the web app service is granted a managed identity in Azure. Now that means that the installation database, which holds the list of which devices to actually install, what is actually out there in the field, which manual should I use, can actually use this identity as a user as for any SQL grants. We can add them access to a table, we can grant them read access, we can be very granular on that. And similarly, we can grant them Azure Data Pane role-based access control access to a storage account as well. Using this setup, we don't have any credentials in code. We have different Azure services connecting to each other using Active Directory credentials. And we can monitor all of these interactions centrally. And here's an example of a little bit different environment, but in this case, this is again a Azure Active Directory registration. This is just one application. In this particular case, this application is called Azure Kubernetes Service Azure AD Server. This is a service that I'm running within my Azure Kubernetes service to provide similar Azure Active Directory login capability as I did natively using the natively built-in app service authentication. So what I need for this Active Directory identity, I need to have access to the Microsoft Graph to actually sign in and read the user profile. And if you zoom in or double click on that, we see that we can actually grant this on behalf of the user. We don't need to provide this, do you consent to reading your data? If this is something that we trust and if this is something that we want. So we have this Azure Active Directory client, which is one Azure Active Directory identity, one service, one application. You may think of it as an API or a front end. And then the AKS Azure AD Server, which is the other application that we have here, which is a custom API, is then something that we can grant access to centrally here as well. We just have here a permission called AKS Azure AD Server. In Microsoft Graph, this is something that's a little bit better described. Perfect. With a full minute to spare, let's summarize what we covered. We talked about the authentication and the security considerations of actually considering the whole identity a security perimeter of its own. We talk about the security built-in functionalities, the data points that Microsoft has there with the intelligent security graph. We talk about role-based access control for granting users access to our Azure environment. We talked about what makes up a role, what's the inheritance there. And we also talked about how to grant access from one service or one application to another. How to grant access for my web application, but for my front end to log in on my behalf to query something in Microsoft Graph API, and how to grant access to the role-based access control, not just for the users, but for applications as well. And we are all done. Thanks for listening to the access control part of our Azure security series. If you have any questions, feel free to ask them here in the chat. I'm more than happy to answer those here. If anything else comes up, feel free to ask those in Twitter. Again, my name is Karl Ots. You can find me in Twitter at Karl J. Ots with the handle. And I thank you very much. Excellent. I have a question. What is next in the series on the Azure security sessions? And that's a very good question, so I'll need to check that myself. I believe the next session is on the 20th of August, and it's about Azure security best practices. And I was actually mistaken. So the next session is actually on the 11th of August about Azure Key Vault deep dive before we actually go into the security best practices on the 20th. You can find all of these and the other expert talks in the Skill Me Up website. Excellent. That's 5 seconds of silence. So I thank everyone for joining me. If you have any questions, feel free to reach out to me on Twitter. And if I went too fast on some of those examples, I know I needed to pre-record the demos, then these will be published in the Skill Me Up website. The slides won't be available, but you will have the full recording at your pleasure. So once again, thank you very much and see you next time.